So in this lesson, what we're going to explore is converting polar equations to rectangular equations. Rectangular equations, remember Cartesian equations. Polar equations involve r and theta. Rectangular equations involve x and y. So there are a few things to keep in mind before we start doing the conversion of the equations. First, let's keep in mind some things that we know about the relationship between x and y and r and theta. So, little review. We know that x squared plus y squared equals r squared. Okay, this is coming from trigonometry. Okay, if we drew a circle, okay, this point right here is the point x comma y. That would be y, this would be x, this is the radius, Pythagorean theorem, x squared plus y squared equals r squared. Now there's something else that we could take if we wanted to isolate r in this equation. What we could do is square root both sides. Okay, if I just write this first as r squared equals x squared plus y squared, if I square root both sides, I get r equals the square root of x squared plus y squared. Now, I can't simplify this because this is not a product inside as the radicand. It's two separate terms. And what we should also keep in mind is x is the same as r cosine theta, if theta was that angle right there, and y is r sine theta. So things to remember: r equals the square root of x squared plus y squared, and x equals r cosine theta, and y equals r sine theta. These are the pieces to keep in mind. Now what we should also review are equations in Cartesian form. So we know a line is y equals mx plus b, but what's going to really pop up here a lot are conics. Now remember, in conics we have circles, we have the ellipse, we have the parabola, we have the hyperbola. Conics, remember, general form looked like this when we set equal to 0. I did not include an interaction term of x times y. We usually don't study those. That's if you were to rotate that conic shape. So remember, if it's a circle, you have both quadratic terms, you have them both, and a has to be the same as b. So when the coefficients are the same, you know it's a circle. If you have an ellipse, you have both of these terms, but a can't be b, but they must be the same sign. Then you know it's an ellipse. If you have a parabola, you only have one quadratic term. So you either have the x squared term, you have the y squared term. And then for a hyperbola, you have both of them, but one is positive and one is negative. That's how you know it's a hyperbola. So let's begin converting. So we're going to convert each to a rectangular equation. Could also have said Cartesian equation. So that means we're going to be given a polar equation. So it's going to be in terms of r and theta, and we're going to have to rewrite it in terms of x and y. So r equals 2 secant theta. So previously you've sketched these things, so you should be a little bit familiar with what you know this is going. If you were to graph this, what you would see. So the first thing that we have to think about is how can we substitute in what we know about the relationship between polars and rectangular equations. So we know that r cosine theta is x, r sine theta is y, and that r we could replace with the square root of x squared plus y squared. Now I could substitute that right away. However, I would be left with this secant theta. Now I don't see anything here that's in terms of secant theta. So we must have some sort of trig identity that allows us to rewrite secant theta, which is 1 over cosine of theta. So we could replace this. R equals 2 times 1 over cosine theta. Now our goal is to end up with this equation in terms of x and y. Now, one thing I notice is I'm very close to having r cosine theta on one side of the equation. If I take the right-hand side and I multiply it by cosine of theta, 1 over cosine times cosine, they're going to cancel out. And cosine of theta times r is r cosine theta. So now I have r cosine theta equals 2. And r cosine theta is the same as x. So x equals 2. I just got rid of the r and the theta. And that's my rectangular equation, which if I graph that, that's going to be a vertical line. So why don't we do another? Number 2, let's do r equals 3 over 1 minus 2 cosine theta. Things to keep in mind, r equals the square root of x squared plus y squared. X equals r cosine theta. Y equals r sine theta. So what we're going to have to do is take this polar equation and figure out how to use substitution so that we can get these equations in there. So right now, okay, I see I have 3 over 1 minus 2 cosine theta. I've got a cosine sitting in the denominator on the right-hand side. Well, maybe I don't want it in the denominator. So what if I multiply both sides by the denominator? So then, if I multiply both sides by the denominator is no longer on the right-hand side. What I have is r times 1 minus 2 cosine theta equals 3. So now, this r cosine theta, this r sine theta, if you can get that in your equation, that's good. That means you can replace it with x, you can replace it with y. I don't have it yet, but if I distribute r, I get r minus 2r cosine theta equals 3. There it is. There's r cosine theta. I get to replace it with x. I have r minus 2x equals 3. Now, I don't have any other trig identity in here involving theta, so all I have left is r. So my one equation is r equals the square root of x squared plus y squared. So at this point, I'm going to have to substitute that in. So the square root of x squared plus y squared minus 2x equals 3. So here's my equation in just x and y. But I want to be able to identify what this is. So I don't want x squared and y squared under that square root. So we have to get x squared and y squared out from under that square root. So in order to do that, we would have to square this term. So we want it isolated on the left-hand side, which means I'm going to have to add 2x to both sides. Now, if I square both sides, I will be able to undo that square root. I'm going to be left with x squared plus y squared equals, and now we have to FOIL 2x plus 3 times 2x plus 3. That's going to give us 4x squared plus 6x plus 6x plus 9. That's going to give us 4x squared plus 12x plus 9. Remember, if we get into the standard form, we see we have both quadratic terms available in this equation here. So right now, we don't have it in general form yet of a conic, but we see that we have both quadratic terms happening here. So our head should turn into, this is some sort of conic going on here. And so we want to make sure one side equals 0. So we have to take away x squared, take away y squared, take away x squared, take away y squared. We have 0 equals 4x squared minus x squared, 3x squared minus y squared. So notice we still have both quadratic terms. So we have both quadratic terms. One's positive, one's negative. This is a hyperbola. And here is the general form of the rectangular equation. And here is what your equation is. It's a hyperbola.